matrix algebra and matrix multiplication. We can look at this by comparison with ordinary algebra. So ordinary algebra here, matrix algebra over here. A, B and C are real numbers. We're going to say that A, B and C are matrices, and we might have to say different things about them as we go through. AB is always equal to BA. We know that 3 times 4 is equal to 4 times 3, for example. AB is not equal to BA in general, and we've seen this. So they're not commutative under multiplication. Not only that, in the work we've done so far, we've seen that one of them might actually be able to be done. So we might be able to do AB and form a matrix, and we might not be able to do BA, or we may end up with matrices of different order. So AB in general is not equal to BA, even if they are of the same order. A times 0 is equal to 0 times A is equal to 0. A times 0 is equal to 0 times A is equal to 0, provided the matrices are of the right sizes to be done. And really, for this to work and give you the same matrix here with AO and OA, it only really works if they're square matrices of the same size. So 2 by 2 matrices or 3 by 3 matrices, and so on. If we expand AB plus C, we get AB plus AC. So this is multiplication being distributed across addition. And that would certainly work with matrices, provided all of the relevant multiplications and additions can be performed. Then we have the associative law. Note it's just the change of the brackets. The A, B and C are the same order. So here we do AB first, then multiply by C. Here we do BC first, then multiply by A. And that's certainly true with matrices. It certainly applies for square matrices of the same size, and it would apply in cases where all the multiplications can be done. Now, A multiplied by 1 is 1 multiplied by A is equal to A. We know that's true. Multiply anything by 1, you get itself. There's something here called the identity matrix. We'll talk more about this later. A times I is equal to I times A is equal to A. That applies for square matrices of the same size. So I and A are both square matrices, 2 by 2 or 3 by 3 and so on. I is known as the identity matrix. A to the n exists for all real numbers A. So we know we can do 2 cubed, for example. A to the n exists only if A is a square matrix. So we can only find A squared if A is a square matrix. If we have A times B equals 0, that means either A is equal to 0 or B equals 0. This is the null factor law which we use to solve quadratic equations. If we have AB equals 0, that can occur with neither matrix being 0. The 2 by 2 identity matrix is this matrix here. I is equal to 1, 0, 0, 1. And note the 1's on the leading diagonal and 0's in the other diagonal. And I'll just put down the 3 by 3 as well so you can see the structure. So we'd call that one I3. Normally this one's called I2. And what happens is we have 1, 0, 0, 0, 1, 0, 0, 0, 1. So once again on what's known as the leading diagonal, it's all 1's and then it's 0's everywhere else.